Hello, programmers! This presentation covers three main topics. We start with a review of scope and visibility and how to declare and instantiate objects. There are a couple of important concepts that need to be understood when working with objects that need to be accessed from different subroutine methods. The Model View Controller Design Pattern, also known as MVC, is discussed. Scope and visibility define where the data can be seen and accessed. Modern programs are typically organized into blocks of data or code with a beginning and end of block. Curly brace languages that are derived from C start with an open curly brace and end with a closing curly brace. Any data or code that is placed within a begin-end block can only be seen within that block. This is called scope and visibility. Everything is self-contained within objects. Instead of having file-level data definitions, you have class-level data definitions. Function scope identifies data defined within the function. For example, func1 defines its own versions of value A and value C. Func1 can access its own version of value A, the file scope version of value B, and its own value C. The file scope version of value A is said to be hidden from func1 because it has its own value A. Func1 is not able to see or access any of the local variables within func2. In a similar manner, func2 can access the file level value A, its own version of value B and value D, but not the file scope version of value B or any variables within func1. A reference for an object must be declared and the object must be given space in memory called instantiation. The address of the object memory is stored in the reference. Assume that there is a class named test that has already been created. The reference can be declared and the object instantiated on the same line of code. Here is a diagram showing the relationship between the reference named T and the object that is in memory. Test T declares a reference named T that would be located in our program's address space. The new operator instantiates the object, meaning creates it, and returns its memory address. The assignment operator, equals, is used to save the address of the object into the reference named T. Our program can then work with the object using the reference named T. The reference can also be declared and the object instantiated on separate lines of code. Looking only at the first line of code, a reference named T is declared for class test. The first line only creates the reference that can hold the memory address of an object if and when it is created. At this point, there is no object, and T contains a null. Since there is no object, any attempt to perform operations on T will result in a null pointer error. The second line of code uses the new operator to instantiate the object, gives it a place in memory, and calls the constructor. The new operator returns the memory address where the object is stored. The assignment operator, equals, takes that address and saves it into T. Now, operations can be performed on the object using its reference named T. If an object is only being worked on inside of one subroutine, then the reference and the object's instantiation can occur within that object. The problem occurs when more than one subroutine needs to work on the same object. In that case, the reference to the object needs to be an area, typically the class level scope, and the first subroutine to be executed needs to be the one to instantiate the object. This may be best illustrated with a sample program. Here is the project definition. Write a graphical user interface GUI program that accepts a number, doubles the number, and displays the result. If a non-numeric value is input, the program is to display an error message instead of attempting to process the data. I am choosing to write the sample program using JavaFX. Since the project definition does not state which language is to be used, a program could have been written in any language that supports a GUI, including C, C++, C#, Java Swing, JavaFX, Visual Basic, Python, etc. It is important to understand the concepts presented here, regardless of the language of your choice. I am going to create a demo program that reads a number from a text field, doubles it, and then displays it in a label. The program is going to be created in 3 steps. 1. Decide the data that is going to be processed, model. 2. Decide what the GUI is going to look like, view. 3. Build connections between the model and the view, controller. One of the first things I did was to sketch on a piece of paper what I wanted the program to look like on the screen. Then I gave names to each of the GUI controls. I have names for LBL title, LBL prompt, TXT number, LBL answer, BTN compute, BTN clear, and BTN exit. I need to decide which of the GUI controls need to be accessed by one or more modules. There is a recommended way to build GUI programs. It is called the Model View Controller pattern. The model represents the data and nothing else. It is not dependent on the controller or the view. In this example, the model is the value input by the user and the answer displayed back to the user. The view is the GUI that is displayed. In this example, the view has labels for the title, a prompt for the input, and the answer to be displayed. A text field is used to input from the user, and 3 buttons are compute, clear, and exit. The controller contains the code in the event handlers. The compute event handler reads the data from the text field, computes, and displays the result in a label. The clear event handler clears the text field and label. The exit event handler ends the program. There are times on some projects where 2 of these things may be combined into one, so don't worry about forcing everything into the MVC pattern. I decided to use the border pane layout available in JavaFX for the display. The border pane is to be placed in the start method subroutine, which will then call separate subroutines named top, left, center, and bottom to fill in the different nodes of the border pane. I chose not to use the right node of the border pane. The top method subroutine will create a label named LBL title to place the title at the top of the screen. The right method subroutine will create a label named LBL prompt for the enter a number prompt and a text field named TXT number. The center method subroutine will create a label named LBL answer used to display the answer. The bottom method subroutine will create 3 buttons named BTN compute, BTN clear, and BTN exit that will call their appropriate event handlers. The controller contains the buttons event handlers that connect the MVC view to the MVC model. The GUI controls are objects, each created and instantiated with their own new operators. The TXT number, LBL answer controls need to have their references in an area of the class definition that can be shared by all method subroutines. That would mean that they are to become class scope variables. The instantiation to actually build the GUI controls using the new operator will be in the left method subroutine called by start when the program first begins running. This is the layout of the code for the program, showing the class scope variables, but not the rest of the actual code. You can click the minus or plus at the left side of the code display on NetBeans or Eclipse to contract or expand different sections of the code to select what you want displayed while you are editing a program. The only expanded part of the code displayed here is showing the class scope variables and object references. The controls for JavaFX text number and LBL answer need to have the references declared as class scope so that they can be seen by each of these methods: left, compute, and clear. The other JavaFX controls do not need their references placed as class scope variables. Now it is time to discuss how to create the objects. In this sample solution, only txt_number and LBL answer have the references placed in the class scope area. Let's look closely at the left subroutine, which is used to build controls that are to be placed in the left node of the border pane. A VBox is used to hold 1. The label named LBL prompt with its text set to enter a number, and 2. A text field named txt_number, which allows the user to enter a number. The reference for label LBL prompt is not declared in the class scope area, and this label is not used in any other method subroutines. Therefore, we can both declare the label and instantiate it with a constructor inside the left method subroutine. The reference for text field txt_number is declared in the class scope area to make it visible to multiple method subroutines. The txt_number needs to be instantiated in the left method subroutine when the form is being built as part of the border pane. Oh no, look at what is happening here. The class scope definition is declaring a reference for text field txt_number, A. This reference will contain a null until a new text field object is instantiated and its memory address is stored in the reference using the =sign assignment operator. The txt_number reference never gets instantiated because at location B inside the left module subroutine there is a different reference created for text field txt_number, and it is instantiated with the new operator. The txt_number at location B as a local variable to the left method subroutine. It has scope only within left and is not visible to the other method subroutines that need to work on it. The other method subroutines only see the reference txt_number in the class scope area, and it has a null instead of a reference to an object. If any method subroutine attempts to access txt_number other than left, a null pointer exception will occur. I hope that you had fun with this and learned a lot about declaring as well as instantiating objects that are accessed by more than one method or subroutine. See you around. Bye.